So, we will start with the OSI reference model. We have studied the basic of this reference model having 7 layers and starting from the physical layer till the application layer in the top. This reference model is basically known as the service oriented reference model. The reason behind is every layer of this model has its own specific services. And what are the services, how the services are being offered or they are being used. We have discussed the peer layer service and the interface and the service interface, those things we have seen. So, now with this reference model, we will first see the 3 lower level protocols or the layers, you can say the physical layer, the data link layer and the network layer. The reason behind considering these 3 layers is usually these 3 layers are considered to be responsible for host to host communication. For host to host communication, if this is the sender side, you have the similar layer, corresponding layers at the receiver side, the file layer, the DLL, the data link layer and the network layer. This also we say the host to host communication. The reason behind is the network layer usually is responsible for finding a source in another network. That means intra-network communication is possible by this network layer because this does the job of routing. So, we will talk about the host to host communication, then to other the process to process or the end to end communication. We will talk about these layers. Starting with the physical layer, this layer usually deals with the kind of signals and the services associated with the signals. What could be the processing of the signals in data communication? First is to detect the error detection, sometimes error correction as well. It deals with all the physical medium. When you talk about the physical medium, usually this could be a wired or it could be wireless. The more about this wired networks and what are the different kind of cables, those things we will study later on. And wireless communication, why this is also used, how the DLL helps in the wireless network, those things also we will study later. And then now after this physical medium, this layer also deals with the technologies like encoding and decoding. Because the signals are converted or the raw data, the 0, 1 bits are converted into the signals and again signals are being deconverted into the 0, 1 bits. So, usually you have different encoding and decoding techniques, those are being dealt by this physical layer. Along with this also deals with the different kind of multiplexing and demultiplexing job. This mostly you will study in the data communication subject. That means physical layer is more of the data communication, how the data is being communicated, how they are being encoded, then transmitted, again decoded, or if required how they are being multiplexed, if required that demultiplexed, the different error correction methods, error detection mechanisms, all those things, those are dealt with the data communication and physical layer is more responsible for this, the data communication. Coming to the next higher layer of this OSI model is the data link layer. As we know, any layer in the reference model, they uses the service of the lower layer and provides the service to the upper layer. So, coming to this DLL, what it does, the DLL provides the service to its upper layer, that is the network layer. So, what it does, it brings the data or the chunk of data from the network layer. It brings the chunk of data, let us say I say that chunk as a packet or I say that is a datagram. Let us give a name to this. So, what the DLL does, it brings the data or the packet from the network layer. In this way, it provides the service to the network layer and now it transmits to its peer layer or the peer DLL the same packet or the datagram, and this DLL in return sends those data to the upper layer, that is the network layer. This is how this DLL in the sender side and the DLL in the receiver side, they provide the service to their upper layer. Now, when this packet comes to this lower layer, that is the DLL, usually they are renamed as the frames. So, we say the chunk of data that is being handled by the data link layer are the frames. When we talk about the frames, means we mean to say we are working in the data link layer. So, when the communication takes place here between this DLL to DLL, this is nothing but a virtual communication. Though the actual communication is through the lower layer, that is the physical layer or the physical media. This is the actual transmission, but we never consider with this. We always say in the protocol, in terms of protocols, always the peer layer they talk with each other. That means they communicate with each other because they only understand what the protocol is and they communicate accordingly. But actually the communication takes place down to the physical layer and again from the physical to the upper layer. But when we say about the protocols, there is a communication to the peer to peer, that is DLL to DLL. Now, how the data link layer provides the service to its upper layer and what are the different kind of services that it provides and how it uses the service of the lower layer, that is the physical layer, we will see now. So, next is the types of the services. The type of the services, those are being supported by the DLL. We know the different kind of services. One is the connection oriented and another is connection less service. These are the two types of services supported by the DLL. Fine. Now, when coming to the connection oriented service, this is a reliable one and this is an unreliable one. In the connection less service, again to make it reliable, one technique is being adopted for this layer, that is acknowledged connection less service. So, DLL has acknowledged connection less service, another is unacknowledged connection less service. This is the first kind of service, the second kind of service, and the third one is on the connection oriented, that is again acknowledged connection oriented service. So, these are the three kinds of services being used by the DLL. The most unreliable being is the unacknowledged connection less. As such, connection less is unreliable. Now, if it is unacknowledged, again the most unreliable is the unacknowledged connection less. Coming to the next one is acknowledged connection less. It is little bit reliable because though there is no connection between the sender and the receiver, but every packet or every frame that is being received by the receiver is being acknowledged. So, an acknowledged message comes back to the sender by the receiver. So, this improves the reliability of the transmission. That is what is your acknowledged connection less service. There is no connection, but whatever data, that packet switching is being used, and in the packet switching every packet or every frame is acknowledged. And the most reliable one is the acknowledged connection oriented. As such, connection oriented is reliable, and again if with this, if you adopt this acknowledgement service, it becomes the most reliable one. So, three kinds of services are being used by the data link layer, right. With these services, how the data link protocols are designed. Now, when you talk about every layer, we will talk about the protocols associated with that layer. Protocols means what is the communication format or the communication link between the peer layers. So, when we say about the DLL, we say about the DLL of the sender side, we say the DLL of the receiver side as well. How the sender side protocol handles, how the receiver side protocol handles. So, what are the services of DLL? The first kind of service is framing. Why you need framing? Let us say I write a sentence like this. I write a sentence like this. Is there any difference between these two? There is. The reason behind is, this is a sentence we can say has no meaning. But if I say this one with the same characters, this is a sentence having some meaning. So, what makes the sentence meaningful? The distinction between the words. We say this is a word. Why? There is a gap between two words and every word has got a meaning, making the whole sentence a meaning to, giving a meaning to the sentence. Similarly, let us say transmission will be like this, 1 0 0 0 1 1 1 0 0 0 something like this, infinity 1 and zeros, right. Other than that, if I say 1 0 0 0 0 0 1 1 1 1 1 1 0 0 0 0 1 1 1 something. Now, you can find some meaning because you can convert these to either a decimal or a hexadecimal or something, and you can find out a meaning, and that meaning will help you to find an error in between. If I have a series of strings of zeros and ones are with me, and in between if any 0 or any 1 is changed or it is omitted or the noise is changed, that there will not be any difference in the output. But if I give a gap in between and something happens to a particular string or a particular word, then I can say there exists an error into this. So, the reason of explaining all this is to say framing is a technique which creates a boundary between the strings of data, and this boundary is being done by giving a gap, a time gap. You can say a time gap between a set of strings of zeros and ones. So, within this time gap of these strings of zeros and 1, whenever the gap comes, something can be done in between the gap. A pause can be taken, there can be any controlling mechanism could be adopted, something could be done, and this helps to have an efficient communication between the sender and the receiver. When the data comes from the network layer to the DLL, what the DLL does, the whole of the datagram that it receives, it divides it into small chunks of data or called the frames, frame 0, frame 1, frame 2 up to frame n. Now, each frame again, this is the data, a chunk of data that it receives from the upper layer, and in between every frame, this is what is called the boundary, frame boundary. So, when I say the frame is nothing but the data from the upper layer and the header information, the trailer information. These are the two control fields, and these two control fields are added by nobody, this DLL. So, what the DLL does, it adds its own header into the data and own trailer into this data, and the whole thing is called a frame. This header information, it indicates some control informations for the peer layer, the receiver layer. It will say what the sender wants to talk to me or send me the message, and accordingly it interprets the data. If the control information says the data contains some 1 KB of size, then the receiver understands that okay, this data is of 1 KB size. If it is less than that, that means there is some error. So, any kind of communication at the talk that between the peer layer of the sender and the receiver will be mentioned by this header information and the trailer information as well. At the same time, it also creates the frame boundaries, the gap between the set of strings. That is what is your framing. Now, when we talk about this network layer and the data link layer, You know the network layer does the job of routing, right? Let us talk about the DLL and the network layer only. We are ignoring the rest of the other layers, though they are present in the network, but because we are concerned about these two layers now, how the communication between the host to host takes place. So, we do not consider the other layers right now. When you talk about this host to host communication, it could be multi-hop, right? It could be multi-hop. Multi-hop meaning, let us say the sender is here in one network in the internet, and there is another network here and another network here. The receiver is here. So, when if the data passes from the sender to the receiver, first it goes to the gateway of this network. From this gateway it goes to the gateway of this network, and again from this it goes to the, somewhere there may be a router who says no, it is not there, it goes to the gateway of the same network, again outside outgoing gateway. Now again it comes to the gateway of this network, and finally it is received to the receiver. And how this is decided? By the job of routing in the network layer. So, when the network layer deals or it communicates, it says or it talks about the network layer only or multi-hop communication. But coming to the DLL, this is nothing but your one hop communication or a single hop communication. So, when we talk about the network layer, and network layer is concerned with the multi-hop communication because the packet has to be delivered traveling from the different hops to the finally to the destination, but the DLL is responsible for one hop communication. That means it has to immediately deliver the packet to the next receiver. The next receiver can be this gateway, again from this gateway to this gateway, or from this gateway to this gateway, this way. That means when the protocol is designed in the DLL, it considers only who is my next neighbor to whom the data has to be transferred. So, this is the difference between these two layers, the routing part and the one hop delivery or the immediate neighbor delivery of the packet or the data to the who is my next hop, the single hop node, right. So, now again this framing, when the frame boundaries are generated or the framing gap is being provided, what are the different methods of framing? Framing could be by a method called a character count method. It could be a byte stuffing method. It could be a bit stuffing method. There are three methods to generate the frames out of the packet or the datagram that is being received by the DLL of the sender side. In the first method, the character count, what happens, let us say we have 10 characters, some 10 to 11, any number of characters are there, right. Now, out of this I will say 5, this 5 and the rest 5 that way. So, the first frame will contain 5 number of characters 10011, and the headers, one field of the header intimates to its peer layer that there are 5 characters present in the frame. Along with the other informations, we are not considering the other informations, right. Now, let us say, and the second frame says, let us say the second frame contains 4 characters, we will stop here. So, the second frame contains the data is 0011, and the header says the number of characters present in this is 4. Similarly, the third frame says the number of characters present in this is 3. These are the 3 frames generated out of the data that was received from the upper layer. Now, the first frame, frame 1, frame 2 and frame 3, they are being communicated over the physical layer to the, this channel, and it is being received at the receiver side. When the frame 1 comes to the receiver understands that the first 5 characters are for the frame 1. So, what it does, it extracts the out of all this data, the 5 characters 1, 00, 11 are extracted from the frame 1, and they are considered as the data for frame 1. Then again the second frame arrives, this says my frame contains 4 number of bits. So, the next 4 00, 11 are being extracted as the data, and similarly for the 110 the 3 bits are extracted from frame 3. So, now the receiver extracts the whole of the data from the different frames, and these are the same as your data that is being sent by the sender. A very simple and a easiest method of finding the data, identifying the data from the header field. But there is a problem associated with this, that is, let us say during communication, during the transmission of the data, some noise and some attenuation, some changes, communication error, this, let us say any of the character count is changed from 4 to it is changed to 5. The field that signifies the characters, number of characters is being changed. What will happen? Now, frame 2 will be considered as 0011 and some data will be taken from the other one. Then again the 2 bits 10 and the rest of the bits will be taken from other. So, subsequently whole of the transmission, your synchronization will be lost. That means the sender sends some data, the same data is being transmitted, but only there is, because of the small change in the header field which signifies the number of characters present in the frame, the whole of the synchronization is lost and you say the communication is not efficient. You get the receiver gets an error at the receiver side saying that this has been lost. That is what is a method of character count, though it is a simple method, but associated with some kind of problem when the transmission takes place. The another kind of framing technique is byte stuffing. This is basically used when the ASCII characters are being transmitted, earlier days, not now. The character count and byte stuffing are usually no more used now, but still the principle of these two are also used for the next one or the currently used stuffing method of designing or the creating the frames. So, the byte stuffing, what it does, let us say you have some characters, some ASCII characters are there, something. What it does, when a frame has to be generated out of some characters, let us say A, B, C, D, L, E, this is the characters to be taken, and what the frame the data link layer of the sender does, it stops a set of characters at the beginning and stops a set of character at the end of the data. This one is DLE STX, indicating data link escape, start of the data, followed by the actual data, this is the actual data, followed by again a set of characters DLE ETX, means data link escape, end of the text. So, these two are the considered as the header informations and they are being stuffed into the string of data. If your string of data is this, they are being stopped here. Sorry, this is not stopped actually, this is being added as the header and the trailer. Now, let us say in the data you have an accidental character in between, you see there is a DLE data, do you find this? In the actual data there is some character DLE. Now, how this DLE will be interpreted by the receiver? Because DLE is always considered as the data link escape or as a control information. So, when this DLE occurs in the, or we say this is the accidental data occurs in the sender side, the actual data, what the sender DLL does, along with the data A, B, C, it stops the same character DLE again, followed by the DLE, the data. So, this is your data and this is your stopped byte, right. Along with this you have same DLE STX and DLE ETX. Now, this is the whole frame that will be transmitted to the receiver. When it goes to the receiver, how the receiver interprets it? It first checks there is a data DLE and the DLE is being followed by STX. If this comes, this will be considered as the frame boundary. That means start of the frame. This is eliminated as the header is being eliminated. or decapsulated. Comes to the next one, the first character A followed by B followed by C. Fine, it is being interpreted as A, B, C. Then after that there is DLE, and this DLE is again followed by a set of another DLE. So, when it sees a series of DLE sequences, or whenever there is two consecutive DLEs present in the received frame, it de-stops the first DLE. So, the sender stops it and the receiver de-stops it, the receiver. Now, this DLE is de-stopped, what remains is the DLE followed by another DLE, and this DLE is again followed by another ETX. That means this is the trailer information, or this has to be decapsulated. That means a set of DLE will be stopped by the sender if the same set of characters occurs in the data, actual data, and as many as times that will be found in the actual data, that many number of DLEs will be stopped. Let us say your data is ABC DLE something, then again C95D LE again, and again A9523 something like this. That means for this DLE you will have a stopped DLE here, the DLE, and for this DLE again you will have another stopped DLE here. So, every time the receiver receives a frame having two consecutive DLE rattling escape set of characters, it immediately de-stops the first one, and second one is considered as the actual data, and the further processing takes place. That is what is your byte stopping method, which is mostly used for transmission of the ASCII characters at that time. The principle of stopping and de-stopping was very nice, but because the ASCII characters are no more used for transmission, so this byte stopping method now was replaced with another stopping technology called the bit stopping. Because the characters were used as DLE STX and DLE ETX in the character stopping, for bit stopping again a set of characters or set of bits you can say is used, a 0 followed by 6 ones followed by a single 0. Now, this is considered as the frame boundary in bit stopping method, and at the end also you have the same set 0 followed by 6 ones followed by a 0. These are called the frame boundaries. And you will see now any protocol they have a format of head delimiter or the frame delimiter. We say also the frame delimiter. It is a 8-bit data or a 1 byte you can say. Usually 1 byte is left for this frame boundaries. So, 1 byte for the header and 1 byte for the trailer at the frame boundary. Now, in between you have all the series of 1100, 1111, 100010. Let us say this is the actual data, correct. Now, this is the whole thing is now a frame and it goes to the sender. When it goes to the sender, let us say 1, 2, 3, 4, 5, 6, let us say this is a 0 again, this is a 0, right. So, it comes to the receiver side, the receiver first checks there is a 0 followed by 6 ones followed by a 0, that means this 1 byte is as the frame boundary. So, it decaps, eliminates as the header information. Now, the actual data starts from here 0, 1, 1 all those things goes. Now, when the 1 comes, it checks how many ones are there 1, 2, 3, 4, 5, 6, 0 again. Do you find this series again? So, when the sender knows that I have a data of the same set of character as my boundaries, what the sender does, when sending the data, before sending, what it does, when it sees 5 consecutive ones at a time, after this 5, what it does, it stops a 0 here. Irrespective of whatever will be the next data or the bit, he does not consider. When he sees 5 consecutive ones, it immediately stops at 0. Then you may have a 1 0 0 0 1 0 again, right. Now, when it comes to the receiver side, receiver finds 0 followed by 6 ones followed by a 0. What it does? It decaps, then it goes to the data. It reads all this data and finds that after 5 ones there is a 0. Whenever the receiver finds a 0 after 5 consecutive ones, it immediately de-stops it. That means that is only a stopped bit, it does not have to do with any data. So, this is de-stopped and the rest of the things are again added to this and considered as the data. And this is a very popular, and now in every framing technique, any packet or any frame boundary techniques, this bit stopping method is used, where you have a single 0 will be stopped after every 5 consecutive ones by the sender side, and the same will be de-stopped by the receiver, and the rest of the thing will continue as it is. This is what is your framing technique. So, you have in the framing, one is the character count method, a very simple method. A header information says how many characters are present in the frame. Then another method is the stopping method. Either you can stop the character or you can stop the string of bits. When the characters are being stopped, we say that is a character stopping method, and the string of bits are a bit is stopped in between, we say that is a bit stopping method. So, these are the 3 methods by which the framing is being done.